In this lecture, let us consider an electric circuit, find the block diagram representation and reduce it. So to find the block diagram representation of this electric circuit, first of all we have to find the Laplace transform of the network. So therefore, to find the Laplace transform of the network, we have Vi of t becomes Vi of s, and then C1 becomes 1 by C1s, and this is 1 by C2s, and the output is V naught of s. And let the currents be I1 of s and I2 of s. So in the first loop the current is I1 of s, and in the second it is I2 of s. So in the first case we apply KVL to the first loop. So when I apply KVL to the first loop, what do we get? So we get the input voltage Vi of s equals I1 of s into R1 plus 1 by C1 of s into, so I have I1 of s minus I2 of s. Alright, so now let us rearrange this expression. So let the output be I1 of s and let the input be Vi of s. So we have Vi of s equals I1 of s into R1 plus 1 by C1s, and I can take this term to LHS, so that becomes plus 1 by C1s I2s. So Vi of s plus 1 by C1s into I2 of s is equal to this. So this is the expression here. So I basically have I1 of s equal to Vi of s plus 1 by C1s into I2 of s divided by this expression, which is R1 plus 1 by C1s. Now this entire expression can be written in the form of a block diagram. So how can we write this? I have Vi of s, and then you have a summer, and here what do we have? We have I2 of s. Now I2 of s is multiplied with 1 by C1s, and then we have 1 divided by R1 plus 1 by C1s. And what about the output? The output is I1 of s. So this is the partial block diagram what I get for the KVL when we apply it to the first loop. Now when I apply KVL to the second loop, what happens? Let us write. So we apply KVL to loop 2. So when we do this, we get, of course, R2 into I2 of s plus 1 by C1s. So here it is I2 of s minus I1 of s, and then you have plus I2 of s into 1 by C2 of s equal to 0. So I have this expression here. So now let me take I2, where I2 is the output and I1 is the input. So we have I2 of s into R2 plus 1 by C1s plus 1 by C2s, and I1s into 1 by C1s, I'll take it to the other side, so it becomes plus 1 by C1s into I1s. So what is I2 of s? I2 of s is nothing but equal to 1 by C1s into I1s divided by this entire factor, which is R2 plus 1 by C1s plus 1 by C2s. So this again can be represented in the form of a block diagram. So how can that be represented? So I have input is I1, and then I have this entire expression 1 by C1s, the whole thing divided by, or I can just write it as 1 by R2 plus 1 by C1s plus 1 by C2s. So these two multiplied and the output is I2 of s. So I get one more transfer function here by considering the KVL which I apply to the second loop. So finally, I have the final expression. What is that? V naught of S is I2 of S into 1 by C2S. So the final expression V naught. So V naught of S is nothing but I2 of S into 1 by C2S. So now let me combine all the three of them. So here I have I2 output and input is I1 of S. Here output is V naught of S, input is I2 of S. So let me combine this here. So I would get 1 divided by C1S into R2 plus 1 by C1S plus 1 by C2S. Alright, so the input here is I1S. Now the output of this is I1 and here the input is I1 here. So this block can be combined here, I can fit this block here. So now if I rewrite this block, so let me erase this. So I have Vi of S given to a summer and then I have 1 by R1 plus 1 by C1S, and what is the output? The output is I1 of S. So here the input is I2 to this. So I2 is here and I have 1 by C1S in the feedback path, and that becomes the input to this summer. So this is the final expression. So I have Vi of S as the input, these two block diagrams, and then I have the feedback path multiplied by 1 by C2S with the output V naught S. So now this block diagram can very easily be simplified. So the first thing is, of course, these two can be multiplied because they are connected in series. So I would get this expression, this transfer function into this. So I can just multiply these two. And then if this is G of S and this is H of S, I have a plus sign here. So it's going to be G of S divided by 1 minus G of S H of S. So let me do the feedback path. So to get the expression, this entire thing is G of S. So I have G of S is 1 divided by R1 plus 1 by C1S into 1 divided by C1S into R2 plus 1 by C1S plus 1 by C2S divided by 1 minus this expression into this. So I have 1 divided by R1 plus 1 by C1S into 1 by C1S into R2 plus 1 by C1S plus 1 by C2S. Right? So this into 1 by C1S. So this is the entire feedback path. So this expression, this gets simplified as this. So now considering the denominator here, so if I try to simplify this, so here I have C1S in the denominator, so this gets multiplied with R1 C1S plus 1. So 1 divided by I have. So the whole thing into, again here I have 1 divided by C1S. So if I take the denominator common, which is C1S C2S, so I have R2 which gets multiplied with C1S C2S. So R2 C1S C2S plus, of course, I have C1S plus C2S. So this is fine, and then again in the denominator I have 1 minus, again this simplification remains the same as this, so I have 1 divided by R1 C1S plus 1 divided by C1S into this term, which is 1 by C1S into R2 C1S C2S plus C1S plus C2S, the whole thing divided by C1S C2S, and the whole thing into 1 by C1S. So now what are the things which can be cancelled? So let us see what can be cancelled here. So C1S can be cancelled. So similarly here C1S can be cancelled. Alright. Now the remaining term can go to the numerator. So here I have C1S can go to the numerator, C2S also can go to the numerator. So let's try to simplify this. So again, trying to simplify this, so I write the numerator, which is C1s C2s divided by R1 C1s plus 1 into this expression, which is R2 C1s C2s plus C1s plus C2s divided by, so here what do I get? So I have 1 minus this same expression, which is, so now if you observe, this C1s and C1s also can be cancelled. So I would get, in the numerator you will just have C2s divided by, the denominator of course remains the same, R1 C1s plus 1 into R2 C1s C2s plus C1s plus C2s. So this is the feedback part. So now if I take the denominator here common, so I would get this expression minus C2s. So let me again simplify this here. So finally I would get C1s C2s. So these two expressions get cancelled, the denominator, if I take this common. So I would get this entire expression here, which is R1 C1s plus 1 into R2 C1s C2s plus C1s plus C2s minus C2s. So this is the final simplified expression of this feedback loop. Now this is now multiplied with 1 by C2s. So what I'll do is I'll just multiply it with 1 by C2s. So C2s gets cancelled. So the final expression would be C1s divided by R1 C1s plus 1 into R2 C1s C2s plus C1s plus C2s minus C2s. So this is the final expression, which is nothing but equal to V naught of S. So this is V naught of S by Vi of S. So this is the final expression, what we get, the transfer function of this electric circuit. So this is how we simplify the electric circuit, get the block diagram representation by considering the Laplace transform, and then we simplify it and finally get the transfer function V naught of S by Vi of S. So after this example, in the next video we shall start with the signal flow representation. So how is signal flow representation important? How can we find the transfer function of any given circuit by using signal flow representation? We shall see that in the next lecture. Do not forget to like, share and subscribe, and press the bell icon to get notifications of further uploads, and thanks for watching.